Hi everyone, we're on our third day of 7.3. We're answering the question today, when we have given roots, are these solutions to the given quadratic function? So looking at this first problem, we have roots of a -1 plus 2i and a -1 minus 2i. Are those solutions to this quadratic equation, yes or no? Well, here's how we're going to go about doing this. What we're going to do here is, if these are roots, it means that's what x, if these are roots, that's what x equals. So x equals a -1 plus 2i, and x equals a -1 minus 2i. Now, this has a 0 on the right, so let's get a 0 on the right side. We're going to do that by adding 1 and subtracting 2i to both sides. So we're going to get x plus 1 minus 2i. That's going to be one factor that equals 0. And then we're going to add 1 and add 2i to both sides to get a 0 on the right side of our second one. So x plus 1 plus 2i equals a 0. Now we have two factors that equal 0. We're going to multiply those two factors by each other. So this factor multiplied by this factor. So we have x plus 1 minus 2i multiplied by x plus 1 plus 2i. That equals a 0. So we have a trinomial times a trinomial. I kind of like to call this foiling on steroids. It's going to be multiplying the first term by everything in the second trinomial, the second term by everything in the trinomial, and the third term by everything in the trinomial. So it's certainly a process, but I want to encourage you, after you're done doing this, you shouldn't get any i's in your answer. So all of your i's should cancel out, which is encouraging to help you know that you're doing this right. So let's take x by everything in the trinomial. So x times x is x squared. X times 1 is a positive x, and x times a positive 2i is a positive 2ix. Moving on to the middle term, we have our 1. 1 times x is x. 1 times 1 is 1, and 1 times 2i is 2i. Our third term, a -2i times x, is a -2ix. A -2 times 1, a -2i times 1 is a -2i. And finally, a -2i times a positive 2i is a -4i squared. That equals 0. Whew! Alright, let's now kill some of these terms. This is my favorite part. We have 2ix's, and a -2ix's make 0ix's. They're gone. We have a positive 2i and a -2i. Those cancel. Boom. Done. Now we have a -4i squared, which is a -4 times a -1. Right, class? I squared is a -1. So this term right here becomes a positive 4. Alright, let's get our terms, combined like terms here, get them all together. We have 1x squared term, so that takes care of that. We have 1x plus 1x is 2x. So we have, I wrote that weird. We have an x squared plus 2x, and then we have our constant terms of 1 and 4, which make a positive 5. So we have 1x squared, 2x's, and a positive 5. That equals 0. What do we find when we go back up to the top? X squared plus 2x plus 5, x squared plus 2x plus 6. So, are the given roots a solution to the quadratic equation? Your answer is 2 letters, and those 2 letters are N-O. They are not. We get a no for problem number 1. Takes a lot of work, but nothing that we can't handle. Why don't you guys pause the video and try this one on your own in problem number 2. You should have got x to equal 2 plus I and x to equal 2 minus I, which means you should have got x minus 2 minus an I equals 0, and x minus a 2 plus an I equals 0. Let's set both of these factors equal to 0 and multiply them by each other. So x minus 2 minus I multiplied by x minus 2 plus an I. That equals 0. Here we go. When you did this on your own, you should have gotten x squared minus 2x plus an ix A negative 2 times the trinomial is a negative 2x, a positive 4, and a negative 2i. Then you should have gotten a negative ix. We're on the third term now. A negative ix plus 2i minus an I squared. That equals 0. Let's cancel off some of these terms. A positive ix and a negative ix make 0 ix's. A negative 2i and a positive 2i, those cancel out. And then we have a negative 1. A negative I squared, and I squared is negative 1. So this right here makes a positive 1. So we have one x squared term. That takes care of that. A negative 2x and a negative 2x make a negative 4x. And then we have 4 plus 1 to give us 5. So are our given roots solutions to the equation of x squared minus 4x plus 5, x squared minus 4x plus 5. Hopefully everyone got yes for problem number 2. We get a yes on that one. Let's try problem number 3. Why don't you guys try this one on your own again to give you a little bit more practice. So you should have gotten x plus 3 minus 2i equals 0 for one of the roots, and x plus 3 plus 2i equals 0 to give you the other factor. Let's multiply these factors by each other. X plus 3 minus 2i multiplied by x plus 3 plus 2i equals 0. Now that we're going to multiply, we get an x squared, a positive 3x, a positive 2ix, a positive 3x, a positive 9, and a positive 6i, a negative 2ix, a negative 6i, and a negative 4i squared. That equals 0. Let's see what cancels here. 2ix's and a negative 2ix's, those are history. A positive 6i and a negative 6i, those are gone. And then we have a negative 4 times a negative 1 in our last term, which gives us a positive 4. So hopefully everyone got x squared, positive 6x's, and then 9 plus 4 is 13. That equals 0. Is that what we see back up top? X squared plus 6x plus 13. X squared plus 6x plus 13. It's so great, isn't it? We get the answer of yes. Those are solutions to our given quadratic function. Number 4 is slightly different, but we're going to do it the same way. Instead of i's, now we have radicals. But just like our i's cancel out when we multiply the factors, our radicals are going to cancel out when we do the factors as well. So that's another check on whether or not you're doing it right. X equals a negative 2 plus square root of 5, and x equals a negative 2 minus square root of 5. We still get two roots, two solutions. Let's set them equal to 0. So x plus 2 minus the square root of 5, that equals 0. And x plus 2 plus the square root of 5, that equals 0. Here we go. Multiplying by each other. X plus 2 minus the square root of 5 multiplied by x plus 2 plus the square root of 5. That equals 0. Multiply the first term of x by everything in the second trinomial. So x times x is x squared. X times 2 is a positive 2x. X times square root of 5 is x square root 5. Second term of 2 by everything. Plus 2x plus 4 plus 2 square root 5. Third term by everything, a negative square root 5 times x is a negative x square root 5. A negative square root 5 times 2 is a negative 2 square root 5. And third term, a negative square root 5 times a positive square root 5 is a negative square root 25. That equals 0. Alright, let's get rid of some of our radicals here. They're gross. Let's get them out of here. X square root 5 and a minus x square root 5 makes 0 x square root 5s. We have a positive 2 square root 5 and a negative 2 square root 5 to give us 0 square root 5. And then we have a negative square root 25. The square root 25 is the same thing as 5. And because there's a negative sign on the outside, it's a negative 5. Okay, so we have an x squared. That takes care of that. We have 2x and 2x, which gives us 4x's. So now we're done with those. And then we have 4 and a negative 5 to give us a minus 1. So we got the equation x squared plus 4x minus 1. What do we got up here? X squared plus 4x minus 3. No! This is not, the roots are not the solutions to our quadratic function. 4 is no. You guys pause the video, try number 5 on your own. When you did this, hopefully you got the answer yes. You should have gotten x squared plus 2x minus 5 equals 0. So if you have questions on that one, why don't you just check with me in class when you get there tomorrow. Let's quickly try number 6 and number 7. Number 6, we have a denominator, so it makes it maybe one step higher in difficulty level, but nothing too difficult. 1 plus I square root 15 divided by 4, and x equals a negative 1 minus I square root 15 divided by 4. So we got i's in this one, we got radicals in this one, and we have a denominator in this one, but our process is still going to remain the same. Let's first multiply both sides by 4. That way we get rid of the denominator. So now we get 4x. That equals a negative 1 plus I root 15. And now we're going to solve for 0 on the right side. So add 1, 4x plus 1, and then subtract I root 15. And that way you get a 0 on the right. So let's do the same thing over here on our other root. Multiply it by 4. So you get 4x equals a negative 1 minus I root 15. And then we're going to add 1 and add I square root 15. So 4x plus 1 plus I square root 15 equals a 0. Are you ready for this? We're going to have a trinomial times a trinomial, and they are massive. 4x plus 1 minus I square root 15 multiplied by 4x plus 1 plus I square root 15, and that equals a 0. Whew! Here we go. The first term in the trinomial by everything in the second trinomial, which is 4x. So 4x times 4x is 16x squared. 4x times 1 is a positive 4x. And 4x times I square root 15 is a positive 4ix square root 15. What a mess. Let's take this 1 times everything. So 1 times 4x is 4x. 1 times 1 is 1. And 1 times I square root 15 is I square root 15. And now our last term might get kind of squishy. A negative I square root 15 times 4x is a negative 4ix square root 15. A negative I square root 15 times 1 is a negative I square root 15. And a negative I square root 15 times a positive I square root 15 is a negative I squared square root 225. Hoofta. That all equals 0. Let's get rid of these radicals and these i's, shall we? 4ix square root 15 and a negative 4ix square root 15 are gone. Positive I square root 15 and a negative I square root 15, those are gone. This last term right here, an I squared is a negative 1, and the square root of 225 is 15. So now we have this negative 1 times 15, and then we also have this negative out there. So it's kind of like this. So we're going to end up with a positive 15, because a negative times negative is a positive. So we get a positive 15 for our last term. So as we simplify, we have 16x squareds. We have 4x plus 4x, which gives us 8x. And then we have 1 plus 15 is 16. And that equals 0. So at first glance, we see probably a no, because we want to get to here. However, at first glance, we say no. At second glance, let's take a look. Can you take out a GCF? Hopefully everyone's like, you can take out a GCF. You can take an 8, an 8, an 8 out of all three of those. So then you would get 2x squared plus an x plus a 2 is equal to 0. Now if we divide both sides by 8, poof, that's gone. Divide this by 8. So then we would get the answer 2x squared plus x plus 2 equals 0. Is that what you see back up top? 2x squared plus x plus 2? 2x squared plus x plus 2. So this is indeed a yes. Alright, last one. Again, it looks intimidating. It's not actually all that difficult. We have 5 roots. X equals 0, x equals 4, x equals a negative 4, x equals 4i, and x equals a negative 4i. Man, oh man. Let's get all of these set equal to 0. The first one's already done for us. That's nice. X equals 0. X minus 4 equals 0. X plus 4 equals 0. X minus 4i equals 0. And x plus 4i equals 0. So now we have 5 factors. Here they are. Let's multiply all of them by each other and set it equal to 0. So we have x times x minus 4 times x plus 4 times x minus 4i times x plus 4i. All of that equals 0. Knowing this, we're going to now multiply and see what equation we get to. Class, it might make sense to you to multiply from left to right. However, I'm going to advise you not to do that, and that's because it's not very efficient. Whenever you multiply conjugates by each other, the middle 2 terms cancel out when you FOIL. So it's always best to multiply conjugates by each other. So multiply these 2 by each other, and multiply these 2 by each other, because they are indeed conjugates. So let's just bring this x straight down for now. And now let's multiply these 2 terms. Well, we have x times x is x squared. Here's a positive 4x and a minus 4x, which gives us 0. They're conjugates. Middle 2 terms cancel out. And then we have the last times the last gives us a minus 16. So we have that. In the same way, these are conjugates. First times the first is x squared. Outside is 4ix. Inside is a negative 4ix. They cancel out. And then we have our last times the last is a negative 16i squared. A negative 16i squared, isn't that the same thing as a negative 16 times a negative 1? Which would give us a positive 16. That equals 0. Now you have 3 factors that you got to multiply by each other. Again, you might think let's multiply from left to right, but I say let's not multiply from left to right. Let's multiply the conjugates by each other, because the middle term is always going to cancel out. So this term and this term are conjugates. So let's just bring this x straight down again. And now we're going to have x squared times x squared is x to the 4th. Here we have a positive 16x and a negative 16x squared, which gives us 0x squareds. And then a negative 16 times a positive 16 is a negative 256. Now you just have 2 terms. Let's distribute. So we have x times x to the 4th is x to the 5th. And x times negative 256 is a negative 256x. That equals 0. So, is this equation the one that we're looking for? X to the 5th minus 256x. X to the 5th, oops, minus 256. That should have been an x. That's my fault. Sorry about that, class. So, we do indeed get the answer yes for this one, because our equation matches our equation down here. So we get yes. Bottom line for this one, whenever you see conjugates, make sure you multiply those by each other before you multiply by anything else. There's our lesson for today. Let me know if you have any questions when you get to class tomorrow.